In this video, I'm going to show you a Motorola Alert Monitor radio. These radios are a little different and somewhat rare as they were not general-purpose consumer radios. They were used typically by fire departments and other emergency services. These radios are crystal-controlled radio receivers, typically on the UHF or VHF bands, with some special tone decoder circuits. These circuits would detect when a tone or sequence of tones was received, and the radio's audio would turn on as well as an alert indicator. They also had an optional relay to activate an attention-getting external indication. From this magazine ad I found for these radios, it looks like they were marketed probably from the 1970s for emergency responders as a new way to reach your firemen instantly. A dispatcher would then send some tones to the units needed to activate their alarm, and then followed it by a broadcast message so a specific unit or station so they could respond. The planning and logistics for the departments is remarkable. You can actually hear some of these types of tones at the beginning of the 1970s TV show. Ah, yes, Emergency. I love that show. Motorola used a component device called a Vibrasponder, which is an electronic tuning fork in effect. When a correct audio tone is received, it causes the reed in the tuning fork to vibrate. Vibration actually makes an intermittent contact with a switch circuit that can either enable more sequential tone decoder circuits or eventually just turn on the alert circuit. The tones were generated by a similar device called the Vibrasender. I will leave a link to a document if anyone is interested in the details. This demo model's version, however, is even more specialized, and it uses a more traditional tune filter circuit instead. In the 1970s, when this radio was built, we see 162.55 megacycles, and I think it's called WX1 today, was the first channel, and 162.4 megacycles, which I believe is weather channel WX7 today, which is the second and probably why these two channels were included in this radio, because at the time, these were the only two frequencies used. The code is 1050 hertz. Is the attention tone that sounds just before the alert message was broadcast. It's interesting that they used hertz but not megahertz. The system was very similar to the existing EBS system of the 1960s. The weather alert spec calls for a 10-second tone, and then the receiver shall react within 5 seconds. The radio was probably the result of a super tornado amp break in 1974. This radio was built 50 years ago and in 1974 as well. Of course, this was before they called it NOAA Weather Radio. The NOAA Weather Radio service was defined in 1975, and the current system of EBS and SAME systems in use today. Fortunately for this radio, the 1050 Hz tone is still in use today. This radio has a few simple controls. Starting from the bottom left is the power volume control. It is pretty much self-explanatory, except the audio level is kind of important for the alert function. The squelch control is not very useful in the weather alert version as the audio is broadcast 24/7. The three switches are the channel select switch. F1, F2 sets to one of the two frequencies of the weather service broadcast you are interested in receiving. The reset momentary switch clears the alarm, and finally the alert MON switch sets the mode to either monitor the broadcast in the MON position or to set the receiver to respond only to the 1050 Hz home tone in the alert position. The two indicators are P for power on indicator, which is green, almost blue in this radio, and the A for alert, red indicator indicating the alert was heard. This lamp stays illuminated until the reset momentary switch is cycled down. The reset switch can also be used to momentarily listen to the audio levels to verify the signal is okay without putting the receiver in the monitor mode. Here is a quick demo of the controls. First, let's turn it on and set to a reasonable volume. Next, this is how to monitor the audio and the alert mode. Now let's set it to F2 to show the squelch action. On channel F2 there's no audio on this frequency. Now let's set it to the alert mode and wait for an alert. Okay, we're waiting for the weekly test. Sorry for the unsteady camera. Wow, that was the first real alert I ever got on this radio. Weird I didn't hear the tone and no announcement. Let's just go ahead and reset. Okay, it works. Let's take a closer look at this particular radio, serial number P05CP2. There are a couple of minor issues I found, but overall this unit works fine. The interior of the radio is in overall remarkable good shape. Just a quick look again at the rear panel. The power input is a 4-pin plug. Interestingly, 2 pins are AC and the other are DC inputs on the same connector. The fuse is for AC only and is a 3/16 amp fuse. The DC fuse is a 1 amp slow blow type, which is contained in the cable's cigarette lighter plug. The RCA plug next to the fuse is not an audio connector, but it is for an external antenna. When the antenna adapter cable is plugged in, it mechanically switches out the internal antenna. The 1/4-inch jack is for an external speaker, and the 2-pin connector, I originally thought it was for a DC input, but they are the relay contacts for an external alarm. Under the info tag, there's a missing screw that is part of the internal antenna assembly that is missing from this unit. This is the side of the radio where the handle was attached. In the handle there was a telescoping antenna. I'm a little curious what the requirement was for this handle and why the antenna pulled out from the front. If anyone watching this has ever used one of these types of units or knows anything else about them, please leave a comment below. With the back cover removed, you can see a large copper leaf. This is electrically connected to the antenna input jack and apparently connects to the telescoping antenna when not using the external antenna. The inside of the unit is remarkably clean. The power supply on the right-hand side with the large power transformer close to the center of the unit. The nice large oval PM speaker behind the front grill. The RF board under the circuit board to the left, which is the tone decoder board. I really like the classic hand-drawn PCB. Note that the decoder board is just partially populated. I think the hand-drawn copper traces on the bottom side are so beautiful. The dense circuitry on the left is the solder side of the RF circuits, and the right-hand side are the power supply components solder side we saw from above. This video is getting a little long, so I'll just do a quick troubleshooting explanation to show you how I fixed the major problem with the alarm circuits in this radio. I knew it was broken because it was not responding to the weekly alert tests. So what we're looking at here is we're looking at the solder side of the decoder board. Looking from the top, we see this adjustment. I had no idea what it adjusted. I was really hoping this radio had a Vibrasponder. I wanted to do a slow motion video or some experiments to see if I could see the reed actually vibrating when you hit the frequency. So the schematic, I went online to look for a schematic or service manual, and I couldn't find one for the VHF model, which is an MO3 series. But I did find one posted for the UHF MO4 series. I read through the manual, which showed the decoder board was probably the exact same one used between the two units, which makes sense as far as a stocking, and if you're making radios, you want to have interchangeable parts. So zooming in on the schematic, we see R109, which is a 10K pot. It's a drive adjustment. And there's a coil that adjusts the center frequency, which is L101. So these are adjustments for a single tone decoder. So looking at the layout, just to double verify what I'm looking at is probably the same. R109 sits right in the center of the board, and there it is. And L101, they're showing it off board. So there's another subboard that contains that. So back at the schematic, we see this test point, which is M101 meter point. The waveform should be W5, which is showing about a 3.2 volt, and I assume the output would be 1050 hertz, which is our target frequency. So that's the adjustment I needed. So looking at the board itself, I just connected the scope to R114, which is an 18K resistor. You can see it just above the L101 to the right, and R109, which is this guy there. So I adjusted with L101. I adjusted L101 with the board pulled out in this configuration, and adjusted R109 with the decoder board back in place. So what I used to inject a signal into this board was my trusty Tiny SA, Tiny Spectrum Analyzer. You can set it up to have a test signal come out of one of the outputs of the device. So here are the settings that I did on the board. So this is my test signal. I set the low connector to output, connected a small antenna to that. Next, I adjusted the frequency to the channel 2, F2, which doesn't have anything locally here near my shop, and set it down to a fairly low level. So I'm directly across from it. It's on the same bench, so I shouldn't be causing any hate and discontent with this low signals. And then I set the modulation to our 1050 hertz or 1.050 kilohertz, and the modulation was on narrow FM. And if you want to set the receiver to spec, you can get the manual. I'll leave a post in it. Hopefully it'll still be there. If not, I'll put it in somewhere where you can get to it. That they do have an alignment procedure where you can set everything. For this fix, I simply set the alert on with F2, on F2, with the scope probe on the 114, and then I just peak the waveform. And this is what my test setup looked like. So the Tiny SA is ready for test and adjustment, and I did not alarm right away, so I had to adjust the R109 slightly, and then it was alarming fine. Okay, there you have it, another radio from my collection. I have several more to demo, so if you made it this far, give it a like, comment, and subscribe. Thanks for watching. Until next time.